welcome to the deep dive. Today, we're tackling something I think pretty much every modern data platform runs into.
Ooh,
That relentless fire hose of information,
yeah.
the stuff that just keeps coming. And we're not just talking neat rows and columns here.
No, you mean the messy stuff.
Exactly. Images, audio, video, all that, truly unstructured data.
Absolutely. And, well, this deep dive is all about navigating that exact challenge, specifically using Databricks and figuring out the best ways to actually build pipelines that can handle it all reliably.
Right. And our guide for this, it comes from a really, really good source. It's a best practices document prepared for beloved organization by Sri Sivakumar Ramar, dated today, June 17th, 2025.
Mm-hmm.
And it really lays out a clear path using Databricks for processing both that sort of traditional streaming data and those trickier unstructured files.
Yeah, so our mission here, really, is to unpack the core strategies from that guide and pinpoint the specific technical steps. We want to pull out those, key nuggets of knowledge that are going to be most valuable to you if you're facing these kinds of data challenges on Databricks.
Okay, so what's on the agenda? What are we digging into?
Mm.
Well, we'll start with the world of continuous streams, how you pull data from places like Kafka or cloud storage folders.
Right.
We'll get into essential concepts like why you really need to be explicit about your data structure, your schema, and how you handle data that shows up late watermarking.
Yeah, that's crucial.
Then we'll kind of pivot to the file-based challenge, getting images, text, other binary files into the system, pulling out useful info.
Metadata, yeah.
Metadata, right? And even processing their content, maybe using external tools.
And we definitely have to spend some time clarifying the magic behind Databricks autoloader feature, specifically using that cloudFiles source.
cloudFiles. Heard a lot about that.
Yeah, it's a real game changer for efficiently getting files from cloud storage.
Okay. So by the time we wrap up, you listening should have a much clearer picture of these powerful patterns and why they're considered best practices in this guide. Sound good? Let's start unpacking this stream then.
Okay, yeah. So the guide, it kicks off by focusing on ingesting and processing those continuous data streams. It lays out a pretty robust pattern for getting data from, various sources into a state where it's ready for transformation.
Right, and it highlights a couple of main source types, doesn't it?
It does. There's Kafka, which you see a lot for things like database change, data capture, CDC, or maybe application event streams.
Yeah.
And then there's using directories in cloud storage, maybe for API outputs that get dropped as files or other event-driven stuff.
Makes sense.
But what's really insightful here, I think, is the emphasis on using the right source connector for the job. So for Kafka, you're, directly connecting to brokers specifying topics, pretty standard. But for those file-based sources, the ones sitting in cloud storage, the guide strongly, strongly recommends autoloader with the cloudFiles source format.
Okay, so cloudFiles again. Why is it so recommended there?
Well, it's not just another file reader. It's specifically designed to efficiently detect and process new files landing in cloud storage, which is, dramatically more performant than older ways that might just list entire directories over and over again.
Okay, so cloudFiles is really optimized for just finding what's new incrementally. That makes a lot of sense, actually. Now, the guide also stresses some initial setup steps. What are the absolute must-dos it calls out?
Well, first, a simple one, but good for operations. Always name your Spurk session. Helps with monitoring.
Okay.
But the critical one, the non-negotiable for reliable streaming. Define your schema explicitly. The guide makes a very strong case here. Don't rely on schema inference for streaming.
Why not? Seems convenient sometimes.
It can seem convenient, but it can lead to really unpredictable errors or even silent data corruption if the schema suddenly changes midstream without you realizing.
Ooh, yeah. Don't want that. Okay, so explicit schema. Got it. And when pulling from Kafka, it mentions using starting offsets latest.
Mm-hmm.
Why that specific setting?
Right. So unless you have really specific reason to go back and reprocess historical data, like from the very beginning of time for that topic.
Which is rare for a new stream, usually.
Exactly. Starting from latest is generally the best practice for new streams. It just ensures you only process data arriving from the moment your stream actually starts up. Prevents duplicates, keeps your logic focused on the live feed.
Okay, good tip. So data's flowing in, maybe from Kafka, maybe files via cloudFiles. The guide shows you might need to, combine these.
Exactly. Using operations like .union. Simple enough. But here's a vital point the guide really stresses. You must validate that the schemas of the streams you're trying to union are actually compatible before you try the union.
Check before you combine.
Yeah, if the structures don't line up, the union's going to fail, or worse, produce garbage results. Sounds basic, I know, but it's a really common pitfall.
Okay, good warning. So streams are combined, maybe cleaned up a bit. Then you get into the actual processing. The guy talks about transformations and watermarking. I hear that term a lot with streaming. What is watermarking really doing for us here?
Watermarking, yeah, it's essential whenever you're doing stateful operations on streaming data.
Hmm.
Things like aggregations based on event time. Say you're counting events within a 5-minute window, like the example in the guide.
Okay.
See, in streaming, data doesn't always arrive in perfect order, or even on time. It can be late.
Right. Network delays,
Well,
source issues.
Exactly. So watermarking provides a threshold based on the event time in the data itself that tells the streaming engine, okay, it's now safe to finalize this window and, crucially, discard the state for events that arrive too late.
So it stops the engine from holding on to information forever, waiting for potentially super late data.
Precisely. Without it, the state the stream needs to maintain for those windowed calculations could just grow and grow, boundlessly, really. Eventually, it eats all your memory, boom, stream crashes.
So watermarking is basically the memory management mechanism for late data in stateful streaming.
That's a great way to put it, yeah. It sets a boundary. Like, the guide shows a 10-minute watermark on the event time. Anything later than 10 minutes past the window close just gets dropped.
Okay, that makes sense. Very important. And after all this processing, transforming, watermarking, where does the data finally land?
The guide is unequivocal here. The recommendation is Delta Lake.
Delta Lake. Why Delta?
Well, Delta Lake provides those absolutely crucial A/D transaction guarantees. That's what makes writing the stream output reliable.
AC. Atomicity, consistency, isolation, durability.
Exactly. It ensures writes are atomic. They either fully succeed or not at all. And it also handles schema evolution gracefully, which is a huge plus when your source data might change over time.
Reliability again. Okay. And tied directly to reliable writing or syncing is checkpointing. The guide really hammers this home too, doesn't it?
Oh, absolutely critical. This is a major, major best practice. Every single streaming query must have its own unique checkpoint directory.
Unique. No sharing.
No sharing. These directories, they need to be in reliable cloud storage, obviously. But checkpointing is how Spark structured streaming tracks its progress, its state. If your stream fails, maybe the cluster goes down or something, the checkpoint allows it to restart exactly where it left off. No data loss, no reprocessing data it already finished.
And if you shared a checkpoint directory?
Disaster. You'd corrupt the state for both streams. It's just a surefire way to get errors, failures, incorrect results, unique checkpoints always.
Unique checkpoints per stream. Got it. Loud and clear. Any other configuration details mentioned? Triggers, maybe?
Yep.
For stability and predictability, the guide actually prefers using micro-batch triggers, something like trigger processing time. It suggests avoiding the continuous triggers in Databricks unless you have a very specific low-latency need, because micro-batching generally gives you better control and visibility into each processing cycle.
Okay, microbatch triggers. And what about monitoring? I think it mentions listeners.
Yeah, monitoring is vital, right? For any production pipeline. Streaming query listeners give you hooks to track the stream's health, its progress. You can see how many rows are being processed per batch, latency, its termination status if something goes wrong. It's basically your window into how the stream is behaving.
Makes sense. You need to know what's going on. Okay, that feels like a really solid overview of the, let's call it, structured and semi-structured streaming patterns from the guide. But what about the really challenging stuff, the images, audio, video files, or just raw text files, that truly unstructured data? Right. This is where the guide shifts gears a bit. It provides patterns for handling data that, well, just doesn't fit neatly into a predefined table structure. The general approach it outlines is ingest the raw files first, maybe extract some useful metadata about them, and then figure out the best way to process the actual content inside.
Okay, so step one is ingestion. How do you even ingest, say, millions of images sitting in cloud storage efficiently and incrementally? Listing directories for millions of files sounds painful.
It is painful and slow. And that's exactly where autoloader shines again. For ingesting binary files, images, videos, audio, whatever, from cloud storage, the guide recommends using autoloader with cloudFiles, but specifying the binary file format option.
Binary file.
Yeah. This tells autoloader, hey, don't try to parse this like JSON or CSV. Just read the whole file as raw binary content. The really cool part is the data frame you get back. It contains the raw file content plus useful metadata that's immediately available, file path, modification time, size.
Automatically.
automatically. It's a super efficient way to get those files into your processing pipeline incrementally as they arrive.
So cloudFiles is pretty versatile then. It's not just for text or JSON or CSV. It handles raw binary blobs too.
Absolutely. It's the recommended high-performance way to incrementally ingest files from cloud storage across all sorts of formats, including binary file.
And getting that metadata out is easy once they're ingested that way.
Yeah, dead simple. The guide shows that once you've read using binary file, the data frame just has columns for path, modification time, length, and the content itself as binary data. Selecting those is just standard Spark data frame stuff.
And you'd want to store that metadata somewhere reliable.
Definitely. Cataloging this metadata, maybe in Delta Lake again, using checkpointing, just like with structured streams, that's crucial for traceability, auditing, knowing what you've processed.
Okay, what about text files? Things like logs or maybe articles. They don't really have a schema, but they're not raw binary like an image.
Good question. For text files, the guide shows using the .text source format with readstream. This basically ingests each file line by line into a data frame that just has a single string column, usually called value.
Okay, one line per row.
Right. Now, if those text lines do actually contain structured data, like maybe each line is a JSON string.
Like logs often are.
Exactly. Then you can parse them out using functions like from JSON. You'd provide an explicit schema for the JSON, similar to how you'd handle JSON payloads coming from Kafka.
And storing that parsed text data, let me guess.
Yeah, the pattern is consistent. Use Delta Lake, use checkpointing. It ensures reliable storage, avoids duplication if the stream restarts. Consistency is key.
Okay, now the really interesting part. Processing the actual content of an image, figuring out what's in it, or say, extracting insights from audio, that sounds way more complex than just getting the file path and size.
It absolutely is. And the guide acknowledges this complexity. It highlights a key best practice here. For that kind of sophisticated content analysis, image recognition, NLP on text, audio transcription, it's often most efficient to leverage specialized external services.
Like cloud provider AI APIs.
Exactly. Think Azure Cognitive Services, AWS Recognition, Google Cloud Vision AI, things like that. They're built for this stuff.
Okay, but how does your Databricks pipeline talk to those external services?
So the guide shows you can orchestrate calls to these external APIs from your Databricks pipeline, often using something called a user-defined function, or UDF.
A UDF, okay.
Your pipeline ingests the files, maybe using cloudFiles with binary file. Then a UDF takes, say, the file path, or maybe even the binary content. It makes the API call out to the external service, sending the relevant data. The service does the heavy lifting, the image analysis, the text processing.
And brings the result back.
And the UDF brings the processed result back, which you can then add as like a new column to your data frame in the pipeline. Now, the guide does add a note of caution. UDFs calling external services can sometimes become a bottleneck if the API is slow or you hit rate limits. So you need careful design, maybe batching calls.
Right. Performance considerations. But essentially, Databricks acts as the orchestrator, farming out the complex AI tasks to specialized tools.
Exactly. That's the pattern. And then, of course, you'd store those results, the image captions, the detected objects, sentiment scores from text, alongside the original file metadata, probably in Delta Lake again.
Makes sense. So those insights are readily available for analysis later, or maybe feeding machine learning models.
Precisely.
It really does feel like Delta Lake for storage and these robust streaming configurations like checkpointing are just foundational across all these patterns, structured or unstructured.
They really are. And consistent monitoring, using those streaming query listeners we talked about, recommended for the unstructured pipelines too, just as much as for the structured ones. You still need to know they're healthy and making progress. And the guide mentions spark.streams.await any termination as being useful if you're running multiple of these unstructured streams concurrently.
Good operational tip. Now, you mentioned earlier the guide has an appendix specifically on cloudFiles. Can we just circle back to that for a second? What's the absolute definitive takeaway there about its role?
Yeah, the appendix basically reinforces that cloudFiles, which is built on autoloader, is the definitive Databricks native, highly efficient way to incrementally ingest new files arriving in cloud storage. It's not just, a slightly better version of old methods. It fundamentally changes how the system discovers new files compared to traditional approaches.
How do those traditional approaches usually work, and why is cloudFiles so different and better?
Well, traditional ways of reading files incrementally from cloud directories often rely on repeatedly listing the entire directory and then comparing that massive list to some kind of state log to figure out, okay, what's new since the last check?
Right. I can see how that gets slow.
Incredibly slow. Imagine you have millions or even billions of files in a folder. Listing that directory every few seconds or minutes is hugely expensive in terms of API calls and time. It just becomes a massive bottleneck.
Okay. And cloudFiles.
cloudFiles uses much smarter discovery mechanisms. Often, it leverages cloud provider event notification services, things like S3 event notifications or ADLS Gen 2 event grid subscriptions.
Oh, so the storage tells Databricks when a new file arrives.
Exactly. Or if event notifications aren't feasible, it uses highly optimized file listing strategies that are far, far more efficient at just identifying what's new without needing to scan everything every single time.
So it completely avoids that costly full directory scan. Wow. That sounds genuinely like revolutionary for file ingestion at scale.
It really is. That's the core of its power. It's optimized for very low latency detection of new files, and it can scale to handle directories with just vast numbers of files pretty effortlessly. It really solves that classic performance headache of continuously monitoring large cloud storage locations. Plus, it handles things like schema evolution automatically if you need it, works across the major clouds. It's just the way to go.
Okay. This deep dive has really laid out the landscape well.
Yeah, I think we've covered quite a bit. We looked at those reliable patterns for structured streaming data from sources like Kafka or files using autoloader cloud files, merging streams, applying crucial bits like watermarking, ensuring robust storage in Delta Lake with those unique checkpoints. And then we tackled the distinct challenges of unstructured data, the binary files, the text files, showing how to ingest them efficiently, again with autoloader cloud files, but using the binary file format. Extracting metadata, leveraging external services for the complex content processing, and, again, storing everything reliably in Delta Lake.
Yeah, the guide provides a really clear step-by-step blueprint. It leverages Databricks' key strengths, Delta Lake for that reliability, autoloader and cloud files for efficient ingestion, and just careful stream configuration overall. It really helps you build pipelines that can handle this modern data fire hose, whether it's structured or unstructured, reliably, and, importantly, at scale.
Yeah, hopefully this whole deep dive has given you listening some concrete examples and a clear sense of these best practices to think about when you're building your own real-time or file ingestion pipelines.
Definitely. And maybe it leaves you with this thought to chew on. Given how remarkably efficient Autoloader's cloud files is designed to be, specifically at just detecting new files landing in cloud storage,
Yeah.
what does that efficiency imply about the maybe often invisible operational overhead and the scalability limits we might still be dealing with in older, less optimized file ingestion systems, the ones that are constantly listing huge directories? It really makes you think about the hidden cost of that inefficiency, doesn't it? Especially as data volumes just keep exploding.